How does the call stack use LIFO for function calls? Imagine you're stacking plates one on top of the other. When you add a new plate, you place it on top. To remove a plate, you take the top one first. This is exactly how the call stack works in programming. It manages function calls using the last in, first out principle. When a program runs, every time a function is called, a new block of information called a stack frame is pushed onto the top of the call stack. This frame holds details like the function's parameters, local variables, and the address where the program should continue after the function finishes. Think of it like placing a note on top of a stack to remember where to go back to later. If this function calls another function, a new frame is added on top of the existing one. This keeps stacking up as functions call other functions, creating a layered structure. The most recent function call is always at the top of the stack, waiting to finish. Now, because the call stack uses LIFO, the last function you called is the first one to complete. When a function finishes, its frame is popped off the stack, and the program resumes where it left off in the previous function. This popping process is like removing the top plate from the stack. This order helps keep everything organized. It makes sure that functions return in the reverse order they were called, which is important for the program to run smoothly. It also helps when debugging. If a program crashes or throws an error, looking at the call stack shows you the sequence of function calls that led to the problem. In cases of infinite or excessive recursion, the call stack can grow too large. This often causes a stack overflow error. Knowing that the call stack uses LIFO helps you trace back through the function calls to find where the problem started. So, in simple terms, the call stack pushes new function calls onto the top as they happen and pops them off in reverse order when they finish. This keeps the flow of execution clear and makes debugging much easier. Understanding this process is key to fixing bugs and making your programs run better.